We're going to continue with our algebra review. We're going to talk about solving inequalities. Let's do a little review on inequalities. So to solve an inequality that contains a variable means to find all the values of that variable, just like it did for linear equations, just like it did for quadratic equations. But unlike an equation, an inequality has infinitely many solutions. Usually, instead of an equal sign, we have an inequality sign. So we're looking for a set of numbers that would satisfy this equation, this inequality, if we plug any of those real number values in for our variable. So there's the difference between an equation and an inequality. We're going to get a whole set of solutions as opposed to just one or two solutions. So just like relationships between the equal sign and operations or values on either side of the equal sign, some of those same things hold true for inequalities as well. If we have a relationship between A and B where A is smaller than or equal to B, then I can do the mathematical operations of addition or subtraction on either side of that inequality sign, and I'm not going to change the value. That relationship of A being less than or equal to B still holds true. If I multiply through by a positive constant, a positive value, then that relationship is unchanged. If A starts out the relationship as less than or equal to B, and I multiply both sides by C, that does not affect that relationship. However, Rule 4 says that when I multiply by a negative value, it flips that relationship. If A started out smaller than or equal to B and I multiply both sides by the same negative value, then that reverses the relationship in that inequality. That means, therefore, A will now be larger than or equal to B. If A is positive and B is positive, that's, again, language. This says if A is a positive value, A can't be negative, A can't be 0. Same for B. And A is smaller than or equal to B, then the reciprocal relationship is opposite. 1 over A will therefore have to be bigger than or equal to 1 over B because A is a smaller number. And when I reverse that relationship, 1 divided by a smaller number will yield a bigger value than 1 divided by a larger number. So again, if the relationship between A and B and C and D are as given here, then if I add the two smaller values together and then add the two larger values together, then that inequality is unaffected. It will still be as it began. So those are just some properties or rules of inequalities that we can count on. So let's solve some linear inequalities. An inequality is linear if it has a variable, and the variable is raised to degree 1. So we're going to do the same basic idea in solving linear inequalities that we do in solving linear equations. We want to gather like terms. So I have 3x here is less than 9x plus 4. There are many ways that this can be done. Probably a good process to go through is to keep the positive value. If you're going to combine these like terms, instead of having negative 6 over here and not changing that equal sign, you realize you're going to have to divide through by negative 6, which will affect that inequality value. So what I would do is just subtract 3x from both sides. I would say 0, therefore, has to be less than 6x plus 4. And again, in an inequality, I'm trying to isolate that variable to come up with not the exact value, but a whole set of values that will satisfy this inequality. So I'm going to subtract 4 from both sides. And what that allows me to do is just concentrate on the mathematics, where I don't have to worry about flipping this symbol, or do I flip this, or did I do something by a negative number. I just keep going. And now I'm going to divide both sides by 6. So negative 4/6 is less than x. Now we generally write our variable on the left-hand side. If this is true, this is the same as saying x is therefore greater than, and that simplifies to negative 2/3. So I wait to do that whole flipping the relationship because of the negative until the very last step. It allows me to concentrate on the algebra that's going on, and I don't have to worry about, did I miss flipping that sign in a step that I took. So just one way to do it. Let's solve nonlinear inequalities. So if we have inequalities that involve squares or other powers, we use factoring together with this principle. If a product or a quotient has an even number of negative factors, then its value is positive. If a product or a quotient has an odd number of negative factors, then its value is negative. So we'll see how that works out. So here's what we're going to do if we have powers on our variables higher than 1. We'll still do what we did with the equal sign. We're going to move all the terms to one side and have 0 on the other side. We're going to factor to the best of our ability on one side of that inequality as if it was an equal sign. Then what we're going to do is find the intervals over which this inequality would be satisfied. We're going to determine the values for which each factor is 0, and then we're going to see over which intervals that were positive or were negative. Again, you'll be able to see what we do here. So I want to treat this as if it was an equal sign. So I'm going to have x squared. If this was an equal sign, I would subtract both sides by 5x. I would add 6 to both sides. I would copy down my sign. Here it's an inequality sign, and now I have a quadratic equation. I can factor it. I can use the quadratic formula. I can whatever I want to do. The easiest thing to do here is to come up with the factors. So x times x, two numbers that add to negative 5, but when multiplied give me positive 6. That's a minus 3. Oop, x is already there, and a minus 2. So this says this product, x minus 3 times x minus 2, needs to result in x values that are less than or equal to 0. So let's deal with the equal to. That's what we're comfortable with. We're comfortable with this. So we know those are going to be included in the solution set. So either x minus 3 equals 0 or x minus 2 equals 0. Those are going to be in our solution set. So x equals 3 is one value that satisfies this inequality, and x equal 2 is another value. Now we have to deal with this less than part. I want outcomes, results that are negative. When I have this product, when I multiply these values together, I need that result to be negative. So I need this to be negative or that to be negative, but not both of them be negative at the same time or both of them be positive at the same time. So I need negative values out of x minus 3. I need to know where x minus 3 is negative. And at the same time, where x minus 2 would have to be positive, because a negative times a positive gives me a negative. So that's pretty complicated to do. Another good way to do this is to find your solutions where u equals 0. There's 2, there's 3. And then pick some samples, because we're not going to change negative or positive on this inequality anywhere along this end of the real number line, anywhere along this section of the real number line, or anywhere along that section. So pick some test values. 1 is a good test value. 2.5 would be a good test value, right? and 4 would be a good test value. And what we're going to do is we're going to come back in here and we're going to test to see if the result, putting those x values in there, we're going to test to see if those results are going to give us negative outputs, which is what we're after, or positive outputs. Let me clean this up a minute and let me draw this a little bit better. So we had 2, we had 3, we said we're going to use as test values 1, 2.5, and 4. We were factored to x minus 3 times x minus 2, and we wanted to know where we had a negative product. So if x was 1, we would have negative 2 times negative 2. That is a positive output. So everything along this end of the real number line is going to give us a positive result. So nothing less than 2 is going to give us what we need in this inequality. Now let's put 2.5 in here. We have 2.5 minus 3, that's negative 0.5. Well, I just am interested in the negative or positive part of it. I didn't even really have to come up with the value. If I put 2.5 in here, that's going to give me a positive value. And lo and behold, yes, that's going to yield me negative results. Now let's put 4 in here. If I put 4 in that factor, it's going to yield me a positive result. If I put 4 there, I'll get a positive result. So everything on this end of the real number line is going to wind up being positive. So the values that are going to work to satisfy this inequality is the interval x such that we are on the closed interval because 2 is included and 3 is included, and all real numbers between them on the real number line will yield us something that is less than 0. 2 and 3 will yield us equal to 0. So seems kind of complicated, but not really. Once you do it a few times, it'll be second nature to you, not a problem. Now let's talk about absolute value inequalities. If we have the absolute value of something, this is saying distance. We really want to make sure that absolute value is in your head as distance. So this says the distance from 0, because x is not translated anywhere, the distance from 0 that will satisfy this solution has to be less than a value of c. So here we are at 0, and the absolute value is the distance. So we can go c in this direction from 0 or c in this direction from 0. So there should be 2 solutions to these inequalities that involve absolute value. Again, there's no equal sign here, so negative c and c are not included, but we go infinitely close to them on the real number line. Here, the equal sign is included, so negative c and c are included. Let's just take a second to write these in interval notation. So this would be from negative c up to c using parentheses. This would be from negative c up to c using brackets. This would be all values less than c, so we could say negative infinity up to negative c, not included. And we would union with that the other set, c, not included, up to positive infinity. So that's what that interval would look like. This would look much the same. We never include infinity because we'll never be there, but we can include any real number. See how I'm including c here where I didn't include it there, because that's the difference between the equal sign. And then we would also include positive c and go up to positive infinity, but I should never see infinity with a bracket around it because we're never actually there. We're just close. Okay, so let's see if we can find a solution here. So let's go back, and we know that if we have the absolute value of x is less than c, then what we're saying is that x has to lie in between negative c and c. So let's take that and let's use this. If I have the absolute value of x minus 5 has to be less than 2, it's equivalent as saying that the quantity x minus 5 has to lie in between 2 and negative 2. The distance on the real number line from 5 can be no more than 2 units. If I was going to draw this, This says I'm not starting at x equals 0, I'm starting at x equal 5. And I can go no more than 2 units to the right and no more than 2 units to the left.